In the last couple of years, some of the most incredible discoveries coming out of James Webb Space Telescope have involved a collection of very unusual and very distant objects that seem to exist when the universe was only about 300 million years old. And because these objects are extremely redshifted, meaning that they're only visible in the infrared light, for a very long time it was assumed that these are baby galaxies. But because there is no actual explanation and not enough evidence yet, in the last few months alternative explanations started to describe these objects as potentially something else. What if these are not galaxies and not galactic objects, but instead dark stars? And so that's essentially what we're going to be discussing today. What if a lot of these objects scientists have been discovering are not something we actually are used to in the modern universe, but is something that used to exist everywhere, but no longer does? And so we're going to discuss this concept of dark stars, which, if it does exist, could potentially solve so many mysteries all at once. But to understand what this is and how this explains everything, we first have to take a look at normal stars, just to basically see the comparison. And so in a normal star like our Sun, everything usually starts when a giant cloud of hydrogen and helium collapses under its own gravity. This usually forms what we refer to as the young stellar object, also known as the proplet, and here a kind of a disk-like formation starts to evolve for a few million years until the core of this object becomes hot enough to start nuclear fusion. And it's this nuclear fusion that then creates the star as we know it, which basically produces all of the light, releases all of the energy, and eventually results in a lot more complex elements in the universe. However, a dark star is a hypothetical type of a star that might be powered by something entirely different. And so here these stars would not be composed of normal matter, so not hydrogen and helium, but instead extremely high concentrations of mysterious dark matter, and specifically some types of particles, such as maybe neutralinos, that would then be able to produce extra energy through the process of annihilation. Or basically because they interact with each other, they eventually annihilate, releasing huge amounts of energy. And this annihilation releases a tremendous amount of heat, which just like in normal stars provides enough pressure to prevent the star from collapsing into a dense core, prevents it from forming a black hole, but more importantly prevents the gas from starting nuclear reactions. And because these stars are not limited by the same physics as fusion-powered stars, in theory they can grow to enormous sizes. We're talking about an object containing huge amounts of gas and huge amount of additional matter that's up to about 1000 astronomical units across, or basically 50 times as big as the distance to Pluto. And some models that we discussed previously in the videos in the description even suggested objects up to 10,000 solar radii in size, with masses of millions suns, and even shining with luminosity of billions of suns. And the thing is, this is not just a hypothesis, because some very unusual anomalous objects have been discovered that seem to produce just the right effects. But why exactly is this important, and what mysteries can this possibly solve? Well, it turns out that if dark stars actually exist, they could solve at least 3 major puzzles of cosmology in one single go, with most of these puzzles coming out of observations from the James Webb Space Telescope that current astronomical models actually have a lot of trouble explaining. And so first, I guess, let's discuss which problems we're talking about and what exactly these observations were. Number one is what's known as blue monsters. As always, you can find all of the studies about this in the description below. And here blue monsters would refer to a population of unusually bright, very massive and unexpectedly blue objects that are actually blue because they emit a lot of ultraviolet radiation that has been redshifted over time. They were discovered at very far away distances and redshifts of over 10. And well, first of all, these objects do not appear as a typical galaxy and seem to be extremely compact. They actually seem to be really small in size, much smaller than a typical dwarf galaxy. They also don't seem to contain a lot of dust based on the initial observations, with most of them also appearing very massive, hundreds of millions or even billions of solar masses. And well, if this is a galaxy, we do expect it to have a lot of dust, at least based on conventional models. But all of these objects are dust poor and seem to produce a lot of these super bright emissions. And so quite a few papers in the last few months have been basically trying to figure out exactly what these are and where all of this dust seems to have gone. And so if these are galaxies, they would require an unrealistically dense packing of stars that should actually not be possible. Some of these stars would be practically neighbors and would most likely just collide, exploding as supernova. However, if these monsters are actually single supermassive dark stars, suddenly their brightness and their size fits the observations perfectly. Okay, the number 2 problem we've discussed a lot of times before, and that's the famous little red dots. The other strange compact object that instead of being blue is now red, and here this is once again dust-free sources that seem to emit very similar light, but also don't emit any X-rays. And these are very confusing because they look like massive stellar systems that should not have had time to evolve so quickly. And since their original discovery in the early 2024, this has now become a major subject of studies with a lot of different propositions and explanations that all kind of make sense but have not explained everything yet. And so once again here we have something very compact, possibly just a few hundred light years across, and something that existed extremely early on. Today approximately 400 such objects have already been confirmed, and they all seem to be more or less the same. And though right now one of the most accepted explanations involves some kind of a supermassive black hole enveloped by a massive cocoon of gas, dark stars, or the remnants they leave behind, once again offer a natural explanation that match this almost perfectly. In other words, here it could be dark stars after millions and millions of years of evolution, once all of the gas evolved, and once there is no more dark matter fuel left inside. And so that's the problem number 2. But the problem number 3 is even more difficult, and it's sort of visible right here. The problem of early supermassive black holes that should not have been possible to begin with. And so that's actually a problem for the little red dots as well. If these are supermassive black holes, how are they even possible? Because in some of these cases, we're talking about black holes that are millions or hundreds of millions solar masses existing in an extremely early universe that has just started evolving. And one of the most famous such examples is actually this, UHZ-1, an extremely distant background object that was originally discovered in 2023 and originally was believed to host one of the oldest and one of the most distant supermassive black holes ever detected. Here this was detected using X-rays, which is why scientists believed that this was a black hole. But it seems to exist 470 million years following the Big Bang, when the universe was only about 3% of its current age. So we're talking about a redshift of 10.1, or a distance of nearly 32 billion light years. And the problem here is the mass. It's already between 10 and 100 million solar masses, which seems to be very similar to the total mass of all stars in the galaxy itself. And so here this was the other problem. How exactly did this form? Now obviously some of the explanations suggested that this basically proves that black holes seem to have existed from the early times of the universe, very likely as primordial black holes that collapsed early on. But this still did not explain everything, and especially did not explain why this black hole was so powerful and contained so few stars and so little gas. And so there was just not enough time in the universe for something like this to have formed. But once again, dark stars might provide one explanation. And so in this case, if they run out of dark matter fuel, they actually do collapse into massive black holes, creating these giant monsters almost right away, which would actually explain why we're seeing so many of these objects all over the place, and why so many of them contain so little gas, yet seem to contain a lot of mass despite being really compact and really small. And so in some of these studies published in 2023 and 2025, researchers actually discovered some candidates that might be best explained as dark stars, these objects you see in this image. And though at first these were thought to be galaxies, their spectral signatures, or their light fingerprint, was actually discovered to be a little bit strange, and was surprisingly a lot closer to some of the predicted models involving supermassive dark stars. And even more recently, scientists discovered another object whose signature seems to match the spectrum of these objects, or of these dark stars, even more. And so inside JWST 0, scientists discovered a very specific dip in light, referred to as helium-2 absorption line. And this specific feature is predicted in a lot of models of dark stars, but should not be possible if this is a galaxy, or if this is a star cluster. And so because of this very strange spectral feature, a few studies propose that this might be a dark star after all. Not really a black hole, and not really a galaxy, because otherwise the spectroscopy did not make sense. And additionally, they found very similar features in the other object that you see right here, This one is just a little bit closer. And so because this object existed when the universe was only about 290 million years old, it obviously challenges a lot of existing theoretical models, and it's just very difficult to explain otherwise. But here this is obviously not a conclusive evidence yet. As a matter of fact, we do have to be very careful when making any conclusions about these objects. Now at the moment, nobody actually has any idea what these are. And especially because some of the data is a little bit conflicting. For example, while the helium-2 signal is exciting, additional observations from ALMA telescope also revealed specific oxygen line in many of these early objects. And well, if these objects do contain oxygen, it usually means that they very likely had supernova, which would actually imply the presence of normal stars and not the presence of dark matter stars, which would only be made out of hydrogen and helium. But interestingly, if both signals are present, it might mean that these objects are even more complex, and perhaps these early objects and these unusual galaxies seem to contain signs of dark matter annihilation and traditional stellar evolution. In other words, maybe they're actually both. These are hybrid galaxies containing features from dark stars and typical galaxies. But ultimately, confirming the existence of dark stars would obviously be revolutionary for the modern cosmology. First of all, this would definitively prove the existence of dark matter as some kind of a particle, and a particle that can annihilate, creating additional energy and creating outer pressure, while also providing us with a little bit more science on what type of a particle this is, and if this is actually something we can find near us. Likewise, this would explain so many other mysteries in the universe, and essentially help us understand how everything in the last 13.8 billion years seems to have evolved. But for now, until future observations, and until future discoveries, this is still going to remain more or less hypothetical. And so as James Webb continues to look deeper into the cosmic dawn and even other parts of the universe, we may discover some other objects that could potentially explain everything at once. For now though, it's still unclear exactly what all of these objects are, and it's still unclear exactly what the universe was like in those first few 500 million years. It might have been filled with all kinds of dark matter, it might have been filled with all sorts of black holes, and it might have been entirely different from what we ever imagined. And that's of course the beauty of modern research. We're getting more and more observations pretty much every year, and we're discovering more and more mysteries that are slowly redefining our current concepts and are helping us understand the universe just a little bit better, which means that we'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.